A purr is a sound made by all species of felids. It varies between cats, and from species to species, but can be characterized as a tonal buzzing. The term purring has been used liberally in literature, and it has been claimed that viverrids, bears, badgers, hyaenas purr. Other animals that have been said to purr are rabbits, squirrels, guinea pigs, tapirs, ring-tailed lemurs, elephants, raccoons and gorillas while eating. However, using a strict definition of purring, that continuous sound production must alternate between pulmonic egressive and ingressive airstream. Peters, in an exhaustive review of the scientific literature, reached a conclusion that until then only a purring cats, a unregistered trademark, and two species of genets, Genetta tigrina, and most likely also Genetta, had been documented to purr. Mechanism: the mechanism by which cats purr is ambiguous. This is partly because the cat has no unique anatomical feature that is clearly responsible for the sound, except for a unique -o-n oscillator in the cat unregistered trademark S-brain. One hypothesis, backed by electromyographic studies, is that cats produce the purring noise by using the vocal folds and/or the muscles of the larynx to alternately dilate and constrict the glottis rapidly, causing air vibrations during inhalation and exhalation. Combined with the steady inhalation and exhalation of air as the cat breathes, a purring noise is produced with strong harmonics. Purring is sometimes accompanied by other sounds, though this varies from cat to cat. In the audio samples that accompany this article, the first cat is only purring, while the vocal production of the second cat contains low-level outbursts sometimes characterized as lerps, or yoops. Domestic cats purr at a frequency of 20 to 30 vibrations per second. Eklund, Peters and Duthie, comparing purring in a cheetah and a domestic cat, found that the cheetah purred with an average frequency of 20.87 Hz and 18.32 Hz, while the much smaller domestic cat purred with an average frequency of 21.98 Hz and 23.24 Hz. TZ and Klund studied purring in 4 domestic cats and found that the fundamental frequency varied between 20.94 and 27.21 Hz for aggressive phases and between 23.0 and 26.09 Hz for ingressive phases. TZ and Klund also observed considerable variation between the 4 cats as regards relative amplitude, duration and frequency between aggressive and ingressive phases, but that this variation occurred within the same general range. In a follow-up study of purring in 4 adult cheetahs, Eklund, Peters, Wise and Munro found that aggressive phases were longer than ingressive phases in 4 cheetahs. Likewise, ingressive phases had a lower frequency than aggressive phases in all 4 cheetahs. Mean frequency were between 19.3 Hz and 20.5 Hz in ingressive phases, and between 21.9 Hz and 23.4 Hz in aggressive phases. Moreover, the amplitude was louder in the aggressive phases in 4 cheetahs. Eklund and Peters compared purring in adult, subadult and juvenile cheetahs and reported that while there was considerable variation across most of the parameters analyzed, mainly attributable to degree of relaxation agitation in the animals resting or plying, previously reported observations that ingressive phases tend to be lower in frequency were largely confirmed. Eklund and Peters reported no major differences as a function of age. It was, until recent times, believed that only the cats of the genus Felis could purr. However, felids of the Panthera genus also produce sounds similar to purring, but only when exhaling. The subdivision of the Felidae into a purring cats, a unregistered trademark on the one hand, and a roaring cats, a unregistered trademark on the other, originally goes back to Owen and was definitely introduced by Pocock, based on a difference in hyoid anatomy. The roaring cats, a unregistered trademark, have an incompletely ossified hyoid, which according to this theory, enables them to roar but not to purr. On the other hand, the snow leopard, as the 5th felid species with an incompletely ossified hyoid, purrs. All remaining species of the family Felidae have a completely ossified hyoid which enables them to purr but not to roar. However, Wise al. argued that the ability of a cat species to purr is not affected by the anatomy of its hyoid, that is whether it is fully ossified or has a ligamentless epihyoid, and that, based on a technical acoustic definition of roaring, the presence of this vocalization type depends on specific characteristics of the vocal folds and an elongated vocal tract, the latter rendered possible by an incompletely ossified hyoid. Reasons: it is unknown for certain why cats purr, but the following reasons are speculated. Cats often purr when being petted, becoming relaxed, or when eating. Female cats are known to sometimes purr while giving birth. Purring may have developed as a signaling mechanism between mother cats and nursing kittens. German ethologist and cat behaviorist Paul Lehausen interprets it as a signal that the animal is not posing a threat. Scientists at the University of Sussex showed in 2009 that purring, or some purring, seems to be a way for domesticated cats to signal their owners for food. According to Dr. Karen McCum and her team, purring in the about-to-be-fed context has a high-frequency component not ordinarily present. Humans report feeling an urgency to investigate and satisfy the cat's needs. To wit, feed me. However, this variety of purring seems to be found only in cats in a one-on-one relationship with their caretakers. This soliciting purr is different from a cat's normal purring. Another theory states that purring triggers a cat's brain to release a hormone which helps it in relaxing and acts as a painkiller. This may be a reason why cats purr when distressed or in labor. Scientist at the University of California, Davies hypothesized that a cat's purr can be used as a healing mechanism to offset long periods of rest and sleep that would otherwise contribute to a loss of bone density. The vibrations and contractions of a purr work during both inhalation and exhalation show a consistent pattern and frequency around 25 Hz. These frequencies have been shown to improve bone density and promote healing in animal models and humans. Dr. Leon, one of the scientists in this study, suggests that this finding may be applicable to astronauts during extended periods in zero gravity. Bone density loss and muscle atrophy is a serious concern for astronauts during extended periods at zero gravity. During these periods, musculoskeletal systems do not experience the normal stresses of physical activity, including routine standing or sitting, which requires strength for posture control. Exposing these astronauts to sound frequencies similar to those of a cat's purr could counteract the deteriorating effects of low gravity. See also, kneading, trill consonant, references. External links: Why do cats purr? Cat purr generator, Why do cats purr? Why do Cheshire cats grin? The felid purr, a biomechanical healing mechanism, Robert Eklund's ingressive speech website, Robert Eklund's wildlife page, Robert Eklund's purring page. For film clips of purring waveforms, see purring.org.